Example number 4 is asking us to find missing sites. So in Trig, we use SOHCAHTOA to do two things. One is to find a missing site, or the second thing we can use it is to find a missing angle. So let's go over how to set up the triangle, how to determine which of the three basic trig ratios of SOHCAHTOA we're using, and then how to actually solve it. So step 1, always when we are solving any right angle triangle, is to determine which angle we're using. So always you need to find the angle that you're going to be using. This could be given, or it's the one you're trying to find. But we always need to have a reference angle, the starting point. According to this angle now, we're going to mark our hypotenuse, adjacent, and opposite side. So remember, hypotenuse is the one that is always opposite to the 90 degrees or the longest. The one that other angle that helps make this angle. So there are two sides to this angle. One arm is your hypotenuse, and the other arm is the one that helps make our angle. That angle is called adjacent. Adjacent means next to it. And the side that is completely opposite to your angle is called opposite, O. Once we have done that, we're going to now determine which trig ratio to use. So let's see which side we're trying to find. So I'm going to start by finding the side AB. So if I'm trying to find side AB, AB here is the opposite side. And then we're going to write down SOHCAHTOA here. Now, whichever one of these identities, sine, cos, or tan, we're going to use, needs to have opposite in it because we're trying to solve it. So the two that have opposite in it are either sine or tan. So we can't use cos. Now we also need to be able to use adjacent because that's a given side. There's no point of using hypotenuse because we don't know that side. We can't have two unknown sides. We need to have another side that is known. So now the only one that will have both the opposite and adjacent is tan, because it has both opposite and adjacent. We can't use sine because it has hypotenuse and we don't know hypotenuse. So you're going to set up the tan. So tan of an angle is opposite over adjacent side. That's what this part means. So tan of 74 degrees is opposite. That's what we're trying to find. It's AB over adjacent, which is 109. Okay. So once we have this, in order to solve for AB, you're going to multiply both sides by 109 so that this goes away, and then you're just left with AB. Now we're going to actually input this in our calculators. So when we're trying to put this in our calculator, you want to, again, remember your degrees is in, your mode is in degrees. So you just need to check it once before you start working on it, not for every question. You put 109 times tan of 74. Please make sure you close your calculator, the bracket. Especially if you wrote tan 74 first. Very important to close your bracket. Otherwise, it's going to think that you're taking tan of 74 degrees times 109 degrees. So very important to close this. So our answer comes out to be 380.1281. So what I mean by that is, if you were to type in tan 74 first, make sure you close the bracket and then times by 109. If you don't do that, you will get wrong answer. Okay, So in both cases, doesn't matter which way I multiplied them, I made sure my bracket was closed. So AB to the nearest foot comes out to be 380 feet. So now I know this measurement as well. I just need to do the second one as well. So now I'm going to set up to find the second side, which is AC. Since we're still using the same angle, my labeling still works. I just need to again determine by SOHCAHTOA this time which one of these identities am I going to use. Now that I know more than one side, I have a little bit more freedom, but I'm going to again focus on the one that I'm looking for, that's AC, and one of the given ones, let's say this one. I always like to use the one that's given in the question if I can, just so that if I made a mistake in this part, it doesn't affect my second one. So if possible, I like to use the measurements given to me already. So again, if I'm looking for one of these ratios which has hypotenuse and hypotenuse and adjacent side in them, so that one would be my cos. Again, not sine because that is between opposite and hypotenuse. And I'm choosing not to use this again. So I'm choosing to use cos because it has these two, the ones that I decided. One that I'm looking for, one that is given. So I set that up. Cos of 74 degrees is adjacent over hypotenuse. So cos of 74 degrees is adjacent, which is 109, over hypotenuse, which I don't know. So if you cross multiply with this, this will, or a shortcut is to just exchange these spots. AC will be equal to 109 divided by cos of 74 degrees. And once again, entering in our calculator, that will look like this. 109 divided by cos of 74, and I close my bracket and I press enter. And that gives me 395, and it will just stay as 395 feet. So that's how you find a missing side in a right angle triangle.